Today we're solving problem 15 from the Fall AMC 10B of 2021. Okay. In square ABCD, points P and Q lie on AD and AB respectively. Segments BP and CQ intersect at right angles at R, with BR equals 6 and PR is 7. What is the area of the square? So we have constructed this square-like shape that is met to our requirements. Now the first thing we notice is that, well, it's a square, and according to multiple theorems, these are all just right angles. Okay, so we also notice that this is a right angle. All the right angles in the corners are right angles. After further inspection, we see that these two triangles, all the angles that I basically highlighted, they're basically the same, because all the angles I highlighted are in two big triangles that are congruent. Same side, same angles, etc., etc. So you can prove that they are congruent, and I'll write it out. Triangle APB is congruent to triangle QCB. Okay. Oh, so now we've proved that, it makes things a lot easier. First of all, the hypotenuse for this triangle is 7 plus 6, or 13. So the hypotenuse for this triangle is also 13. Using that knowledge, we can implement the Pythagorean theorem because we have a set of right triangles here. Okay. Now we have to use like substitution to make this easier. Let a variable, call it x, equal the length of segment CR. Yeah, that's how you write it, CR. Okay, this is x. We know that this length is 13, so therefore this side has to be 13 minus x. Okay, well, let's start with segment QB. QB, this segment squared is going to be equal to 13 minus x squared plus 6 squared. Okay. Segment CB squared is equal to x squared plus 6 squared. And these segments, CB and QB, are all part of this one big triangle, where you can use those squares. So this big triangle is QCB, where we can also use the Pythagorean theorem to solve it. And it involves the hypotenuse, which is just 13. So when we add it up, the sum's going to be equal to 13 squared. So let's do that. This is all the squares according to the Pythagorean theorem. This is 13 minus x squared plus 6 squared plus x squared plus 6 squared. And this is going to be equal to 13 squared. Okay. Well, first of all, we have a 13 squared here. This is 169 minus 26x plus 2x squared, because there's one here, and then plus 72, because there's two of these, and 2 times 36 is 72. And this is 169. And we can cancel these out. Okay, now what we're left with is 2x squared plus 72 minus 26x. This is supposed to now equal 0 because we canceled those out. We see that we can divide all sides by 2, so we get x squared minus 13x plus 36 is equal to 0. That's our formula here. We can actually factor it out because this can factor into x minus 9 times x minus 4. This has to equal 0. So we have to determine which x it is and then just plug it in and solve it. Okay, we left off at x minus 9 times x minus 4 is equal to 0. This states that we have two possible answers here, but one is incorrect. We can we can eliminate one answer choice because, well, one of these, because we know that CR is greater than QR. Therefore, x minus 4 is incorrect and x minus 9 is correct because when x equals 9, it satisfies all these conditions. When this is 9, this becomes 4. But what we're really worried about is the area. We can use the Pythagorean theorem to find out the side length. The side length is not the square root of 9 squared plus 6 squared. This is the side length. This is CB. But we want the area. The area is the side length squared. So we have to square both sides to get the area. 9 squared plus 6 squared will give us our answer of 117. So we are done.